Welcome back to Science for Sleep, a place where curiosity slows, where the noise of the world fades, and where science is explored gently without urgency. As you settle in, let your breathing become easy and natural. There's nothing you need to focus on, nothing you need to figure out. Tonight is about limits, not emotional limits, not imagined limits, but the real physical boundaries of the human body. Tonight, we begin a journey toward the absolute edge of what humans can survive. We are asking a simple question with a surprisingly complex answer. How deep can humans actually go? Depth has always unsettled us. Long before we understood pressure or oxygen, humans sensed that going deeper meant danger. Light disappeared. Sound changed. The world pressed inward. Depth is not just distance. Depth is force. And force does not care about intention. The moment a human body enters water, physics takes control. At the surface of the Earth, your body exists under one atmosphere of pressure. It's invisible, constant, familiar. But water is heavy. Every 10 meters you descend adds another full atmosphere of pressure to your body. At 10 meters, pressure doubles. At 50 meters, it increases sixfold. At 100 meters, it becomes 11 times greater than what you feel right now. Your lungs compress. Gases dissolve into your blood. Your nervous system begins to behave differently. The body is still alive, but it is no longer operating under normal conditions. Early humans had no equations for this, but they learned quickly. Across ancient cultures, people dove underwater to hunt, gather, and survive. Pearl divers, fishermen, and free swimmers pushed themselves deeper than comfort allowed. They noticed something strange. As they descended, their bodies became calm. Heart rate slowed. Blood shifted inward. The sensation of panic faded. This was not discipline. It was instinct. Modern science calls this response the mammalian dive reflex. It exists in all mammals, seals, whales, dolphins, and humans. When the face touches cold water, the body automatically prepares for submersion. The heart slows dramatically. Blood vessels in the limbs constrict. Oxygen-rich blood is redirected to the brain and heart. This reflex evolved to protect life, and it still lives inside you. Elite freedivers rely entirely on this ancient reflex. They descend on a single breath. No oxygen tanks. No mechanical assistance. No margin for error. As they descend, pressure compresses the lungs until they partially collapse. Air is forced into the bloodstream. The chest shrinks. Vision narrows. Time begins to distort. At extreme depth, thought itself slows. Yet consciousness can remain. Barely. The deepest freedives ever recorded exceed 200 meters. At that depth, pressure is more than 20 times greater than at the surface. It is not strength that allows survival there. It is calm. The body can tolerate pressure longer than the mind can tolerate fear. Panic accelerates oxygen loss. Calm conserves it. This is why freediving is as much neurological as it is physical. But even with training, even with instinct, the body reaches a limit. Oxygen deprivation eventually overwhelms the brain. Blood chemistry shifts dangerously. Loss of consciousness becomes inevitable. No human can hold a breath forever. Biology always collects its debt. To go deeper, humans needed separation. Technology. Pressure-resistant shells that keep the ocean out, while protecting the fragile body inside. With these vessels, humans have reached the deepest known point on Earth. The Challenger Deep. Nearly 11 kilometers below the surface. At that depth, pressure exceeds 1,000 atmospheres. Enough to crush steel. Enough to shatter bone instantly. Only a handful of humans have ever been there. Inside thick-walled spheres. Protected, but completely dependent. One crack, one failure, and survival would end in milliseconds. Depth exists not only beneath the ocean. Humans have also pushed downward into the Earth itself. The deepest hole ever drilled reached more than 12 kilometers into the planet's crust. No human entered it, because pressure was not the only limit. Heat became the barrier. Temperatures rose far beyond expectations. Rocks softened. Machinery failed. The Earth resisted. Depth also exists in the opposite direction. Space, not pressure, but absence. In a vacuum, unprotected humans lose consciousness in seconds. Blood begins to boil at body temperature. Oxygen escapes the bloodstream. Whether descending into the ocean or ascending into space, the message is the same. The human body survives only within narrow margins. So where is the absolute limit? Most physiologists agree that without protection, humans cannot survive much deeper than 600 to 700 meters underwater, even briefly. Beyond that, oxygen toxicity, nitrogen narcosis, and neurological failure overwhelm the brain. Training can extend tolerance slightly, but not dramatically. Evolution did not prepare us for extreme depth. And yet, questions remain. Why do some people tolerate depth better than others? Why do hallucinations occur at certain pressures? Why can some animals survive thousands of meters below where humans fail instantly? And could technology, or evolution, ever push us further? There are also stories. Claims of secret deep-sea bases. Unverified reports of classified dives. Conspiracy theories suggesting humans have gone deeper than publicly admitted. There is no confirmed evidence, but fascination persists, because depth represents something ancient, the unknown below, the place we are not meant to go, but try to understand anyway. As you listen now, allow your thoughts to drift downward. There is no bottom you need to reach tonight, only quiet understanding. To understand where the human limit truly lies, we need to understand what pressure actually does inside the body. Pressure is not felt the way temperature or pain is felt. It works silently, relentlessly. As you descend, pressure forces gases in your body to behave differently. Nitrogen, which normally dissolves harmlessly in your blood, begins to enter tissues and nerves in increasing amounts. At moderate depths, this causes nitrogen narcosis, a state divers often describe as drunkenness. Reaction time slows. Judgment fades. Euphoria or anxiety may appear without warning. At greater depths, narcosis becomes dangerous. Thoughts fragment. Hallucinations occur. Reality distorts. Some divers report seeing shapes in the darkness. Others feel watched. Some believe they are being guided or warned. These experiences feel profound, but they are chemical. The brain misfiring under pressure. At even greater depths, oxygen itself becomes toxic. Oxygen is essential for life, but in high-pressure environments, it becomes harmful. This is known as oxygen toxicity. Seizures can occur without warning. Vision tunnels. Muscle spasm. Consciousness vanishes. This is one of the reasons why deep dives require carefully controlled gas mixtures. Not too much oxygen. Not too little. The margin is thin. Then there is high-pressure nervous syndrome, a condition seen in extreme depth experiments. Tremors, confusion, loss of coordination. Even when oxygen and nitrogen are carefully managed, pressure alone can disrupt neural signaling. The nervous system was not designed for compression. Signals slow. Timing breaks down. The brain loses coherence. Together, these effects create a biological wall. Not a single limit, but overlapping ones. Each system failing in its own way. This is where animals differ. Creatures that live at extreme depths evolved under constant pressure. Their bodies are built differently. Flexible tissues. Minimal gas spaces. Proteins adapted to compression. Deep-sea fish do not fight pressure. They match it. Humans cannot. Our lungs, sinuses, and blood chemistry make us vulnerable. Pressure does not just surround us. It invades us. Some researchers have wondered whether humans could adapt. Could generations of exposure push limits further? Evolution is slow, and depth offers little opportunity for reproduction. The pressures that kill us do so too quickly. There is no time for adaptation. This makes permanent biological change unlikely. Technology, however, changes the equation. Pressure suits, advanced gas mixtures, artificial habitats, underwater stations where humans live under pressure for weeks. These experiments show something interesting. The body can tolerate sustained pressure if transitions are controlled. Depth itself is not always the problem. Change is. Yet even with technology, absolute limits remain. Materials fail. Systems malfunction. Human error accumulates. Depth magnifies mistakes. At extreme depths, there is no rescue, no margin. This is where conspiracies often emerge. Stories of secret military habitats far below known limits. Claims of classified technology allowing indefinite deep-sea living. These stories persist because depth hides evidence, but no verified data supports them. Physics does not bend easily. Biology does not negotiate. As your breathing slows, notice how the idea of limits can feel grounding. There is comfort in knowing where boundaries exist. The human story is not about endless conquest. It is about understanding our place. Beyond pressure and chemistry, there is another boundary that appears long before the body fails. The mind. Depth isolates. Light disappears. Sound dulls. The sense of space collapses inward. At extreme depths, there is no horizon, no reference, only darkness and instrumentation. This environment places unique stress on the human brain. Divers and submersible pilots often report a subtle psychological shift as they descend. At first, curiosity dominates, then vigilance, then something quieter, a sense of detachment. Time begins to feel distorted. Minutes stretch, thoughts loop. The brain evolved to navigate open spaces filled with sensory feedback. Depth removes that feedback, and the mind responds by turning inward. In saturation diving experiments, where humans live under pressure for weeks, psychological effects often emerge before physical ones. Sleep cycles drift. Dreams become vivid. Emotions flatten or intensify unpredictably. Some participants report a strange calm. Others report creeping unease. The absence of normal environmental cues alters perception of self. This is not panic. It is disorientation. Isolation amplifies these effects. At great depth, communication is delayed or limited. Rescue is theoretical. The knowledge that help cannot arrive quickly changes cognition. Decision-making becomes more conservative. Risk tolerance drops. Attention narrows. The brain prioritizes survival. Darkness plays a role as well. Humans rely heavily on vision. In near total darkness, the brain fills gaps. Shadows become shapes. Sounds gain meaning. Movements feel intentional. This is not imagination. It is pattern seeking. The brain evolved to detect threats, even when information is incomplete. At depth, that instinct has nothing to work with, so it invents. Some of the most compelling reports from deep-sea explorers describe a feeling of presence. Not a belief in something specific, just the sensation of not being alone. Neurologists believe this may arise from disrupted integration between sensory and spatial processing regions of the brain. The mind loses a stable map of the body in space. And in that uncertainty, presence is misattributed. This phenomenon appears in other extreme environments as well. High-altitude climbers, polar researchers, astronauts. Whenever humans enter environments radically different from those we evolved for, similar experiences emerge. Depth is not unique, but it is intense. This leads some theorists to suggest that the deepest human limit is not defined by meters or pressure, but by cognition, by how much unfamiliar reality the brain can integrate without fragmenting. The body may endure longer than the mind. This is where the most speculative theories arise. Some propose that consciousness itself resists extreme environments, that the brain's predictive systems break down when sensory input becomes too alien. Others suggest that humans experience a kind of perceptual ceiling, a limit beyond which meaning dissolves. These ideas are philosophical, not proven, but they reflect something real. Human experience has boundaries. Technology can protect the body, but it cannot fully shield the mind. At some point, depth becomes not just a place, but a state, a narrowing of perception, a thinning of reference. As you rest now, notice how your own environment feels stable. Familiar sounds, predictable sensations. The brain relaxes when the world makes sense. This is safety. In the final portion of our journey, we'll step back and answer the question as clearly as science allows. How deep can humans actually go? And what does that limit tell us about who we are? There is no rush. Let the mind float upward slightly. When all the evidence is gathered, when experiments are compared, when physiology, psychology, and physics are placed side by side, the answer becomes clearer. Not simpler, but clearer. There is no single depth that defines the human limit. There is a range, a narrowing corridor where survival becomes increasingly dependent on conditions being exactly right. Without protection, most scientists agree that the absolute lower boundary for human survival lies somewhere between 600 and 700 meters underwater. At this depth, the combined effects of pressure, oxygen toxicity, nitrogen narcosis, and neurological disruption overwhelm the body rapidly. Survival beyond this point is measured in moments, not minutes. Training can delay failure slightly. Calm can extend tolerance. But the wall arrives regardless. With protection, submersibles, pressure vessels, controlled atmospheres, humans can go far deeper, down to the deepest known places on Earth. But even then, the body does not adapt. It is shielded. The human inside remains fragile, dependent on engineering, dependent on margin, dependent on everything working perfectly. This distinction matters, because it tells us something fundamental. Humans do not conquer depth. We borrow time within it. The deepest limits are not only underwater. Heat limits us underground. Vacuum limits us in space. Radiation limits us beyond Earth's magnetic shield. Every direction has a boundary, and every boundary is shaped by the same truth. The human body evolved for a narrow band of reality. This realization often feels disappointing at first. We like stories of boundless potential, of endless expansion. But limits are not failures. They are information. They tell us where life thrives, and where it does not. There is also a quieter implication. The fact that we can even approach these limits is remarkable. That fragile organisms can survive crushing pressure, near vacuum, extreme cold, and isolation at all. Technology did not give us courage. Curiosity did. The conspiracies surrounding depth persist because the ocean hides evidence. But science has been consistent. Physics is unforgiving. Biology is precise. There is no hidden class of superhumans immune to pressure. No secret adaptation waiting to be revealed. Only careful engineering and respect for boundaries. As you lie here now, consider how rarely we think about limits in daily life. We assume the ground beneath us will hold, that air will always be breathable, that gravity will behave. These assumptions are luxuries of the surface. Depth strips away those assumptions, and in doing so, it teaches humility. So how deep can humans actually go? As deep as biology allows. As deep as technology can protect. As deep as caution is maintained. And no deeper. There is peace in this answer, because it reminds us that survival is not about domination. It is about alignment, staying within the conditions that allow life to unfold. As your breathing slows and sleep approaches, let this understanding settle gently. The world is vast, the limits are real, and within them life is possible. There is nowhere you need to go now, no depth to reach, just rest. Science has shown you the edge. Sleep can carry you back safely. Good night, Crescent Moon.